Now that the new milling cam project is created and the cam part is fully defined, we can begin adding the operations to machine this part. In looking at this part as a whole, we know that we can complete the programming in basically 4 2.5D milling operations, which I'll cover in the next 4 videos. Note that during the programming, I'll also explain some of the parameters we'll be using in depth to help familiarize you with the specific technologies, showing you the how and why we're using them. So let's start off with adding our first operation to the cam part, and then we'll go from there. We'll begin by adding a face milling operation to remove the excess material on top of this part. In the SolidCAM Manager, right-click the operations header. When the menu appears, hover over the Add Milling Operation submenu. As we are presented with a list of operations that we can add to the cam part, select the option of Face. The Face Milling Operation dialog box appears and shows the workflow in SolidCAM. As we move forward with these Jumpstart videos, you'll notice that most operations will follow this same type of workflow. In the operation dialog box and moving down the tree, we'll first define the geometry, followed by creating and choosing a tool, picking the milling levels, defining the type of technology to use, and finally choosing the lead in and lead out tool movements on the link page. Working from top to bottom, let's define the machining geometry. First, click the New button. We have several ways to choose our geometry around the part. The geometry is the boundary that controls where our toolpath will be created. Since our target model is defined, we can leave the default option of Model in the Type section. Under Base Geometry, click the drop-down and select Target from the list. This selection will automatically create a boundary around the outside of the part, and that's exactly where we want our toolpath to work. Let's click OK to accept the selection. Next, we have to define a tool suitable for face milling. To start the tool definition, first switch to the Tool page. Since we have yet to create a tool, I'll show you how to build one in SolidCAM. Click the Select button to bring up the Choosing Tool for Operation dialog box with a Part Tool table. Click the Add Milling Tool button here at the bottom left. For this operation, we'll use a face mill as our tool type. By choosing face mill from the list, we are presented with several options. For this series of Jumpstart videos, however, we're only going to focus on 2 of the tabs for right now. They are Topology and Tool Data. The topology gives us control over the physical dimensions of the tool. As you can see here on the left, we can easily switch between metric and standard units of measurement when entering tool values. Let's leave the default units, millimeters. For this operation, enter a value of 100 millimeters in the diameter field. You can also set things like corner radius, arbor diameter, total length, outside holder length, and cutting length. For this example, leave the remaining default tool parameters and switch to the Tool Data tab. Here we can control our feeds and speeds. We'll use the default values, which give us a feed XY of 100 millimeters per minute and a feed Z of 33 millimeters per minute. Our spin rate will be 1000 RPMs in a clockwise direction. Now, we can click Select to accept the tool definition and to also choose the tool for the operation. Looking at our workflow, next on the tree is the Levels page. The first group we'll look at is the positioning levels. The clearance level value is pulled from the coordinate system settings. The safety distance value is pulled from the MAC file of our post processor. And the second group is the milling levels, which we'll pick right off the model. To define the upper level, which is the top of our stock in this case, click the upper level button. Then, simply pick on the top corner of the stock box in the SolidWorks graphics area. Click OK to accept the selection. Next, we'll define the face depth, which represents the surface we want to machine to. Click the Face Depth button and then pick on the top face of the target model. Click OK to accept the selection. Notice how the milling levels fields have changed color. This is because the values are associative to the picked entities, and if the model changes, these associative values will also change. Now, your background color may be different as defined in the SolidCAM settings, but nevertheless, a highlighted field indicates the associativity of a value. And that completes the milling levels definitions. Let's now move on to the technology page. Now, we have several technologies to choose from, which can be chosen from this drop-down list. When selecting the desired strategy, you'll notice that the technology appears on a separate tab for a more structured placement of parameters. We have our hatch option, which is pictured here, giving us a back and forth toolpath motion, stepping over until the entire top surface is machined. The second option is contour, which follows the boundary chain stepping from the outside in until it machines the top surface. The third option is one pass. Because our tool is wider than the part, we can machine the entire face in just one pass. The last option in the list is spiral, which chooses the machining pattern automatically. For this example, we'll use one pass. Now, let's switch back to the Technology tab for a moment. We also have the option of taking a finish pass by enabling the Finish checkbox and adding a value to the floor offset field. For this example, however, we will not add a finish pass. Lastly, let's switch to the link page. Having selected one pass for the technology we want to use, we only have two options for lead in and lead out. They are none and tangent. None simply means that the tool will not be leading into or out of the cut. By selecting tangent, the tool will lead in and lead out through these values set by us, the user. If we would like to keep our lead out the same as our lead in, we can enable the Same As Lead In checkbox, and it will set the lead out equal to the lead in. For this operation, let's choose none for the lead in and lead out. Now, we can click Save and Calculate to add this face milling operation to the CAM tree and calculate the toolpath. If you are prompted with the message Upper Level is above Coordsys Upper Level, OK, enable the Don't Ask Again option and then click Yes, as we know that this is the case. At this point, let's take a look at the generated toolpath now that the operation is calculated. By clicking the Simulate button, the Simulation Control Panel will appear in a new window. Note that we have several different modes and available options to present our toolpath, which I'll explain later. For now, let's just quickly review the wireframe toolpath. To do that, we'll use the default simulation mode called HostCAD. Click the play button and the wireframe toolpath will be displayed on our model in the SolidWorks graphics area. The generated toolpath feeds down, moves across the part in one pass, and then retracts away. Since this is exactly the result we're looking for, we can now move on to adding our next operation. To close the simulation, click the Exit button. This will take us back to the face milling operation dialog box, which we will also exit. Next up, we'll add a profile operation to our CAM part, which will get us one step closer to completing the part programming.